Example 9. Find the indefinite integral of the square root of x plus 3, all divided by the cube root of x dx. So I'm going to have to do a couple of things here. I'm going to have to split these apart. Remember, if you have a sum over a single denominator, you write each term over that denominator. So I'm going to go ahead and write each term, the square root of x over the cube root of x dx. Remember, whenever there's an integral symbol, you have to have that differential which says a derivative has been taken of these terms, plus the integral of 3 over the cube root of x dx. Now, as we have done with the square root, we're going to have to do the same thing with our cube roots. So we're going to write our square root of x as x to the 1/2, and our cube root of x as x to the 1/3 dx, plus the integral 3 over x to the 1/3 dx. Now this second term, I can go ahead and write that as a negative exponent. 3 times x to the negative 1/3 dx, and I can use the power rule on that. Remember, when you have a variable in the denominator, you're going to want to make that a negative exponent unless it's a 1, right? If you have the integral of 1 over x dx, you can't do that one. You have to recognize that one is the natural log of absolute value of x. But on this first one, I'm going to reduce that just like I would if I had whole number exponents. So let's say I had x to the 5th over x to the 2. Well, you subtract those exponents, right? Because if you have 5 factors of x divided by 2 factors of x, when these are divided out to ones, you get x to the 3rd left. So the easy way is just to subtract those exponents. So I have to do 1/2 minus 1/3. I'll get a common denominator of 6. Well, that's going to be 3 over 6 minus 2 over 6. Because remember, to get a common denominator, in this case, I just multiply 2 times 3, I get 6. I had to multiply this denominator by a 3 and numerator, and this denominator and numerator by a 2, and then that gives me a 1/6. So this is the integral of x to the 1/6 dx. And now we're ready to just use the power rule by adding 1 to the power and dividing by it. So I'm going to get x to the 1/6 plus 1 divided by 1/6 plus 1 plus 3 times x to the negative 1/3 plus 1 divided by negative 1/3 plus 1. And always, when you're taking an integral, you've got to add plus c because you don't know what unknown constant could have been there whose derivative was 0. So a little arithmetic here. That's going to be x to the 7/6 divided by 7/6 plus 3x to the 2/3 divided by 2/3 plus c. And then remember, when you divide by fraction, so if I have a over b divided by c over d, I have to flip that, change it to multiplication. So anytime you divide by fraction, you flip and multiply. So this 7/6 is going to get flipped and multiplied. So that's going to become 6 over 7 times x to the 7/6 plus, now I've got to flip this one, 3 over 2 times 3x to the 2/3 plus c. And the second term, remember there's a 1 under that 3, so my final answer is going to be 6 sevenths, x to the 7/6. 3 times 3 here is going to give me a 9 numerator. So plus 9 over 2 x to the 2/3 plus c. So that is my final answer.